The last section of Chapter 2 will be on Nonlinear Inequalities 2.7. There's more than one strategy for polynomial inequalities. For this book, we're going to find the critical numbers and test the test intervals. And we'll do the same for rational inequalities. If you have another method that works and is correct, you're welcome to use that. Just make sure you show your work. Okay, so I have this inequality, x squared minus 3x minus 4 is less than 0. Okay, so my first step is I'm going to find the critical numbers. And you don't have to write down all these words every time you do it. I'm just doing that because it's our notes. The critical numbers for a polynomial are going to be the zeros. So I'm going to try to find the zeros. Because I'm just finding the zeros, I can make this equal to 0. Okay, let's see. I'm going to factor this. X times x, 4 times 1, minus 4 plus 1. Okay, so I get x equals 4 and x equals negative 1. Okay, these are not my answers because this is an inequality. These are going to be the critical numbers. These are where something important is going to happen on the number line. Okay, I'm going to test and see which part of the number line is going to be useful to me. So I'm going to go ahead and sketch a number line. Okay, the critical numbers are at negative 1 and 4. So I'm just going to go ahead and include negative 1 here and 4 here. Okay, now I know there's going to be, let's see if it's going to be an open circle or a closed circle. Okay, because this is a less than sign, there's no equals. This is going to be an open circle. Or your book, rather than open circle, it likes to use parentheses. I'm fine with it either way, but I'm going to use parentheses to be consistent with your book. But keep in mind, at negative 1 and 4, I'm going to have an open circle or a parenthesis. Okay, and even though I have the numbers that are important on the number line, I don't actually know where to shade or where the solutions lie. So the solutions might lie on this part of the number line, they might lie here, and they might lie here, or they might lie in more than one location, more than one interval on the number line. So I'm going to check some points in the intervals to see which ones work. Okay, let's see. I'm going to go from left to right. So let's see. Say I want to check something to the left of negative 1. I'm going to pick some number to the left of negative 1. How about negative 2? I try to pick kind of easy numbers so I can check them. Okay, when I check them, you don't need to show work because when you get pretty good at these, you can plug them in your head. I'm going to plug it in factored form. Okay, so I'm trying to see if negative 2 minus 4 times negative 2 plus 1 is less than 0. Okay. The reason I like to use factored form is because I can do it without actually calculating the numbers. Negative 2 minus 4 is negative 6. Negative 2 plus 1 is negative 1. If I do a negative times a negative, is that less than 0? No. Okay, this interval is not going to be part of the solution. Okay, let me check the next part of the interval. Okay, between negative 1 and 4, I'm going to pick a number. Because I'm lazy, I'll pick 0. You could pick 1, 2, you could pick 2.5, whatever you would like. You can plug it in the factored form or the general form. It doesn't make a difference. I'm going to put in factored form. 0 minus 4, 0 plus 1, and I want to see if that's less than 0. And because I'm just trying to see if it's less than 0, I don't really need to calculate it. This is going to be a negative times a positive. Will that be less than 0? Yeah, that'll be less than 0. So this interval will work. Let me test the far right interval. Okay, to the right of 4 is maybe x equals 5. Okay, again, you don't need to show your work for the checks. You also don't need to list which number you're checking. Okay, if that's a positive times a positive, is that less than 0? No. Okay, so those intervals don't work, but I can do my number line now. Okay, the only interval that worked was in the middle here. Okay, now at negative 1 and 4, which were my critical numbers, I can put an open circle, and that's correct, or I can use parentheses to match your book's notation. I'm going to use parentheses to match. The parentheses should go towards, they should be surrounding the interval. Okay, this is my number line. That's a correct number line if they ask me to do the number line. They also asked me to solve it. To solve this, I'm going to express it in interval notation, and it should look just like the number line. The interval that worked was this one right here, and it was surrounded by parentheses. So my solution is going to be parentheses, negative 1, comma 4, parentheses. Okay, for the next example, I'm going to solve 3x cubed minus x squared minus 12x is greater or equal to -4. I don't need to graph it on a number line. Sometimes people will still like to graph it on a number line because it's useful to them and it helps them imagine it, but it's not necessary. Okay, the first step in solving this polynomial inequality is I want to find the critical numbers. Okay, and you don't need to write out what you're doing, I'll know. But I'm going to find the critical numbers, which are the zeros. Okay, since I'm finding the zeros, I don't really care about the inequality sign at this moment. So I'm going to make it an equal sign. 3x cubed minus x squared. I'm going to make it equal to 0. So let me add the 4. So critical numbers are the zeros for polynomials. I'm going to see if it's going to group because that's less work than the rational zero test. Okay, that's going to group because I can see the common factor of 3x minus 1. Okay, I'm going to go ahead and keep factoring because I should get 3 critical numbers. Okay, these are my critical numbers. This is not my answer because this is an inequality. It should be some kind of intervals on my number line. This is in no way my answer. Okay, it doesn't require me to make a number line. Some people like to make a quick little number line so they can check each interval that way. The other way you can do that is you can list all the test intervals. Okay, so the test intervals are all the intervals formed by those critical numbers, and they need to be going in order. Okay, and if you draw a number line again, you wouldn't necessarily list out these test intervals. Okay, let's see. I'm going to go from lowest to highest. I'm going to consider the sign as well, the inequality sign. Because this is greater than or equal to, this is going to be either a closed circle at the critical numbers, or it's going to be a bracket. Okay, so that means it's possible the intervals that might work are going to be from lowest to highest, negative infinity to what's my lowest critical number. My lowest critical number is -2. It might be from -2 to what's my next lowest, 1/3. It might be 1/3 to 2. And it might be from 2 to infinity. Since there's 3 critical numbers, there's 4 test intervals. Okay, often the solution intervals alternate, but they don't have to, especially if there's an even exponent involved. Okay, let me check. Okay, let's see. Negative infinity to -2. I'm going to try x equals -3. And again, you do not need to show me your work on your checking. I'm going to assume you checked it. Okay, I plug it in factored form because I'm lazy and it's easier. Let's see, 3 times -3 minus 1 is going to be a negative. -3 plus 2 is a negative. -3 minus 2 is a negative. Is all that going to be greater or equal to 0? No. Okay, let me go to the next interval. Between -2 and 1/3, I'm going to pick x as 0. You do not need to indicate your test number. You don't need to show your check. Okay, I'm going to plug it into factored form. Let's see, that'll be -1, +2, -2. Is that going to be greater or equal to 0? Yes, because negative times positive times negative is greater or equal to 0. Okay, between 1/3 and 2, I'm going to pick 1 because I'm trying to do easy ones. Okay, if I plug it in factored form, 3 times 1 is 1. 3 minus 1, that's going to be a positive. 1 plus 2 is positive. 1 minus 2 is negative. So will that be greater or equal to 0? No. Okay, last one. I'm going to try 3. That's a positive times a positive times a positive. Is that going to be greater or equal to 0? Yes. Okay, so my actual solution is going to be the intervals that work along with a bracket on the critical numbers. So the ones that worked were -2 to 1/3, and I'm using the bracket because it could equal the critical numbers, union 2 to infinity. Okay, our last example is going to involve rational inequalities. The answer should still be intervals, and we are still going to consider the endpoints and everything like that. Okay, my first step is still going to be to find the critical numbers, but the critical numbers on a rational inequality are slightly different. So the first critical number is if I check the domain. Okay, based on the denominator, since x minus 2 is in the denominator, I should be able to tell that x cannot equal 2. Okay, this is actually my first critical number. And it is the fact that x can't equal 2. What does that tell me? It tells me at 2, there's going to be some kind of open circle or a parenthesis, depending on if I'm doing a number line or the test notation, the test intervals. Okay, to find the other critical numbers, I'm going to change this to an equal sign and solve the equation. Okay, I do change it to an equal sign because once I start multiplying by x minus 2 on both sides, I'm going to invalidate the inequality because I don't know if x minus 2 is a positive or a negative, and it actually depends. Okay, let's solve this. X equals -5. Okay, this is my last critical number then. Okay, so I have two critical numbers. I have x can't equal 2 is a critical number, and x equals -5 is also a critical number. Okay, before I progress, I'm going to consider whether this should be an open or closed circle once I get to the solution region. Okay, because this is greater or equal to, okay, this is telling me that my solution to this is going to be either closed or a bracket at that critical number. Okay, which is why at x equals -5, it's either going to be closed, circle, or a bracket, depending on if I'm graphing it or I'm doing the test intervals. Okay, I'm going to list out the test intervals. It does not tell me I need to graph it on a number line, although you might want to use the number line because some people are visual and that helps them. Okay, I know that -5 and 2 are my critical numbers. So for my possible solutions, -infinity to -5 might be an interval that works. I'm going to use the bracket to remind myself that it can equal -5. Okay, from -5, my other critical number was 2. I'm going to use a parenthesis to remind myself it cannot equal to 2. Okay, and then from 2 to infinity. Okay, so 2 critical numbers, 3 test intervals. These often alternate, but you can never tell. Okay, the only problem with these is when you check, you kind of really have to check. There's not really an easy way to check these. Okay, let me see. -infinity and -5. I'll try -6. Okay, and I'm plugging it in the original one because sometimes you got to do it. Okay, -6 minus 2, is that greater than or equal to 3? -25 over -8. Is that greater or equal to 3? That looks like that's 3 point something. So yeah, this interval is going to work. Okay, let's see. Between -5 and 2, I'm going to try 0. 4 times 0 minus 1. 0 minus 2, is that greater or equal to 3? What is that, 1/2 greater or equal to 3? No. Okay, they often alternate, so I'm guessing the next interval is going to work, although sometimes that's not true. Between 2 and infinity, I'm going to try the value 3. 12 minus 1 is 11 over 1. Is that greater than or equal to 3? Yes, it is. Okay, after all that work, I need to make sure I list the solution. Okay, the solution is going to be the intervals that work and with respect and also respecting the endpoints. So -infinity and -5 worked, and then there's a bracket on the -5 because the original problem had a greater or equal to sign. Okay, the other interval that worked was from 2 to infinity. The 2 is a parenthesis because x cannot equal to 2, and I need to respect that.